To quickly prepare potassium iodide from strong iodine solution, you need to measure out about 20 to 30 grams of potassium hydroxide and dissolve in about 100 ml of distilled water, then stir well and warm. Then to another beaker, you pour the strong iodine solution, maybe glucose iodine or normal iodine used to test for starch. Then it gently introduce this hot potassium hydroxide solution into the iodine solution until it becomes almost decolorized. You keep adding until you get a very pale yellow solution, and this pale yellow solution or a colorless solution is containing potassium iodide, potassium iodate, and potassium chloride. Then you take back the decolorized solution and warm gently. Add more iodine solution to ensure that there is no excess potassium hydroxide. When you hit on adding excess iodine, you see that the solution will decolorize again. Then after, you turn to a bigger beaker, about 500 ml beaker, and now evaporate to dryness. On evaporation to dryness, you now get solid crystals which contains mixture of potassium iodide, which is what we are preparing, then potassium iodate and also potassium chloride formed alongside, because this particular iodine solution also contains HCl, because I got it from potassium iodide. Now I want to take it back to potassium iodide. Now remember to cover with the crucible to avoid splashing of the solid on drying or on evaporation to dryness.
How the tide rushes in.
Now, to confirm if there is any trace of potassium iodide, we need to react the resulting crystal with a lead-2 nitrate solution. If it gives us a yellow precipitate of lead-2 chloride, it shows that there is potassium iodide in the crystal. Oh my god, that shows that there is potassium iodide, because that yellow precipitate is lead-2 iodide. So this, now let us confirm if there is potassium in it. Yes, it's giving us lilac coloration. Now when I moistened it with ethanol, you can now see the potassium flame very clearly in that case. So this shows that we have potassium iodide. Now let's see the purification to remove the potassium iodate and the potassium chloride. Apart from science videos, you can also contact us for the following services: setting your standard laboratory with high quality, having your glassware, then get your lab set up in a functional way. Your reagents are available with Her Majesty's World Science Channel physics apparatus, and setting your physics laboratory in a standard functional way with optical implements, biological apparatus. Then enjoy with Her Majesty's World. Thank you so much. In the separation, you can use cascading, that is repeated fractional crystallization, but here I dissolved the mixture in ethanol, about 85 or 90% ethanol, because out of these three mixtures, that is potassium iodate, potassium iodide, and potassium chloride, it is only the potassium iodide that dissolves in ethanol. Now, potassium iodide is bitter. Now I'm testing to confirm if there is any one that have dissolved. Oh my god, that's bitter, of course. Then that shows that I have to filter. When I filter out, the filtrate will now contain potassium iodide, while the residue, we have potassium iodate and potassium chloride mixed together. Then you can see the residue. This is probably the iodate. Now here is the filtrate, which contains the potassium iodide. I have to take back and now evaporate to dryness. If you want to gain back the ethanol, you can use your Libby condenser and now condense the ethanol back again. Now after evaporation, what we now have is pure potassium iodide. But the problem here is that the potassium iodide I recovered by dissolving in ethanol is actually acting as a deliquescent. I wouldn't know why. Now this is the pure crystal of potassium iodide gotten from the evaporation to dryness of the resulting filtrate, and here is the residue, probably the potassium iodate and mixed up with potassium chloride. Now let's carry out some tests to confirm this. Here is our potassium iodide. Probably you keep a sample on a white tie, then collect another one. This is the residue, which is probably the iodate and also the potassium chloride. First, I will use concentrated hydrochloric acid to confirm which is which. So on adding concentrated hydrochloric acid to the potassium iodide, there wasn't any visible release of pure iodine, but on that of the iodate, on adding concaves here, you can see iodine was liberated. So there is a difference between the potassium iodide and the potassium iodate altogether. This is wonderful. You can only see but a little pale yellow in that of potassium iodide, but not pure iodine. This time around, let us still use our lead 2 nitrate. Here is the residue we got, then place it on a different test tube. Add water to dissolve. All the components are actually soluble in water, both the iodide and the iodate, even the chloride. But now, let's use this already shown reaction to distinguish them. This is lead 2 nitrate. On adding it to potassium iodide, there will be a yellow precipitate. Yes, of course, as you can see. Then this is just white precipitate of lead 2 chloride, because I told you it is contaminated with potassium chloride also. So on warming, this particular precipitate is supposed to disappear and reappear on cooling. Thank you.